Okay, so this is a quick review for the pre-cal quiz. It's going to be tomorrow. Here's an example. I'm going to give you a function, not an easy function, and then I'm going to ask you to do these 4 things to it. Okay? So given this function, how would we graph that function? Okay? Well, we're going to come over here, and we're going to solve the function for y so that we can get it in a graphable form. Okay? Is that okay with y'all?
Mm-hmm.
Okay. So what's the first thing I need to do to solve for y?
Distribute the negative 1/2.
Very good. Okay, so I'm going to distribute negative 1/2 to my parentheses here. Doesn't change the left side, so I'm going to rewrite that. This would be negative 1/2 x. Negative 1/2 times a positive 4 is going to be minus, and 1/2 of 4 is 2, right?
Right.
Okay, so that gives me 2. Now I want to isolate my y, so I need to subtract 2/3 from both sides so that I can get this guy canceled out. Okay, that's going to leave me with y by itself on the left. Then I have a negative 1/2 x, and then I have a minus 2 and a minus 2/3. Now, my next step would be to combine these 2 constants. One is a fraction form, one is a whole number. So we need to change 2 to a fraction that represents 2. I'm going to rewrite the first part here. So instead of 2, I'm going to put 6 over 3, because 3 goes into 6 2 times. And now I have a denominator of 3 that matches my denominator fraction. So I can combine these now. Negative 6 and a negative 2 gives me what?
Negative 8.
Very good. Negative 8 over 3. Okay, now I need to graph this. I have it in slope-intercept form now. And in order to do that, easiest way is I need a y-intercept, which I have here is 8 over 3, and I have a slope. But this 8 over 3, it's a little hard to graph, so I want to see what is that equal to. 3 goes into 8 2 times. That leaves me 2/3. Still kind of hard to graph that, so let me change it to a decimal. So instead of 8/3, this is really 2.6. It's an estimate. Okay, so graph it. Where's my intercept?
2.6.
Positive or negative?
Negative.
Okay, so there's negative 2.6 would be about right there. And then what's my slope?
Negative 1/2.
Okay, so I'm going to go down 1 and over 2. Do one more, down 1, over 2. Any questions so far? So I have my function graphed. Okay, what's the next thing I need to do?
Find the inverse.
All right, how do I find the inverse?
Don't you have to draw the y equals line?
Not yet. That's when we graph it.
We
Do
put
what?
y into x. Substitute y into x.
Good. I'm going to write my original function down. Y equals negative 1/2 x minus 8 over 3. Then I trade out my x and y's. So that'll be x is equal to negative 1/2 y. 8 over 3. Now what I'm going to do?
Isolate y.
Solve for y. So I'm going to add this guy to both sides. Cancels that out. Leaves me with negative 1/2 y on the right. On the left hand side I've got positive x and a positive 8 over 3. Now what do I need to do next?
Get rid of the negative 1/2.
And how can I do that?
Oh gosh.
Multiply by its reciprocal.
Multiply by its reciprocal. So I want this to be a negative 2 over 1 here, which means I need to do that also over here. Negative 2 over 1 is the same thing as what?
Negative 2.
Just negative 2, so I can just leave that as negative 2. Okay. How are we doing on time?
It's almost 5 minutes.
Okay, good. So here we've got this gives us a positive 1y because negative 2 times negative 1 gives us a positive 2. 1 times 2 gives us 2. Okay, 2 over 2 is just 1, so we have a positive 1y on the right. On the left, we need negative 2 times x, negative 2x. Negative 2 times a positive 8 over 3. That's going to be a negative 2 times 8, 16. Remember that 1 here? 1 times 3 is 3. So, let me just rewrite this as something we're kind of used to. We're kind of used to the y being on the left. So I can do this without breaking any rules as long as I switch everything. Moving the y to the left side, I'm going to move the left side of my equation to the right. And because I switched to both of them, I don't have to change any signs when I do this. Is this going to be easy to graph?
No.
Because of that, right?
Yeah.
So we need to change that to a decimal. Let's see, 3 goes into 16. How many times?
5.
5. That leaves us with 1/3, so that's 5.3 repeating. Okay, so here's our inverse. Now we need to come over here and graph it. We've got negative 5.3, 1, 2, 3, 4, 5, and a little bit after it for 5.3. Negative 2 is our slope. So we need to go down 2 and over 1. And this is not going to be the greatest drawing. When you do this on the quiz, you'll have graph paper so you can draw this to scale.
So in the quiz, we're going to have to draw the graph, actually?
Yes. Okay, so we have the function graph, that's letter A. We have its inverse, that's letter B. We have the inverse graph, that's letter D. We need to do C, which is test the inverse by composition. Okay, by composition, remember I told you yesterday in class that if you take the function and compose it with its inverse, we should have x left over. So that's what we're going to do. We're going to take our function, and I'm going to start out with our original just so we can see we can do that. We had 2/3 plus y equals negative 1/2 x plus 4. Now I'm looking at that and I have an x here, so that's okay, we can do that. So instead of x, what am I going to plug in?
The inverse equation?
The inverse equation. So I'm going to rewrite my original, 2/3 plus y equals negative 1/2. And then plus 4, my inverse equation will go there. I'll change colors so you can see the difference. Let's see, negative 2x minus, and I want to leave that in the fraction form because 5.3 was an approximation. We have to be careful with approximations. So I'm going to leave it in fraction form. Now I need to simplify this out. See if we get x left. I'm going to distribute negative 1/2 times a negative 2x. You can check me on this, but that will give you a positive x. Because negative 1/2 times negative 2 over 1, those are reciprocals, right?
Yep.
So that gives you a positive 1. Negative 1/2 times negative 16 over 3, that's going to give us a positive 16 in the numerator, 6 in the denominator, because it was 1 times 16, 2 times 3. Negative 1/2 times positive 4, that gives us a negative 2, so I can change that to subtraction, because that's 4 times 1 over 2, so that gives us negative 2. Alrighty. Now we need to solve for y. So I'm going to subtract the 2/3 from both sides. That gives me y equal to x plus 16 over 6 minus 2 minus 2/3. Okay, so hopefully that all of this is going to cancel out, so we're just left with x. But we need to see, so we need a common denominator for these three fractions, or the two fractions and the whole number. Common denominator would be what?
6.
6, right. So, I'm going to rewrite my equation. My first fraction already has 6 as the denominator. My second fraction, to have 6 in the denominator, that needs to be 12. 6 goes into 12 2 times. My third fraction, to have 6 in the denominator, I need to multiply by 2. So 3 times 2 is 6, 2 times 2 is 4. And let's see, we've got 16 minus 12, which is what?
4.
4. 4 minus 4,
0.
0. 0 over 6 just goes to 0. So we are left with y equals x, which is how we check the inverse function. Okay, before we stop, any questions for our viewers at home?
Should we expect hard equations like this with fractions and decimals?
It's a possibility. I want you to be ready for the worst case scenario. I'll cut that out. All right, thank you. Just hit